Hi, how's it going? Pretty good? Wow. All right, so I think I'll start off with a joke to get everybody warmed up. Uh, what kind of pants does Mario wear? Mario Brothers. Denim, denim, denim. Denim, denim, denim. All right, terrible joke, I'm sorry. Okay, my name is Ben. You can find me on the internet at Subdigital. And today I'm going to be talking about Swift on Linux. You may know me from NS Screencast, where I produce weekly screencasts on iOS development. And I've met some of you here who have been a subscriber for a while, and so that's really heartwarming to me to come halfway around the world and to meet somebody who has seen my work. A while back, I got excited about Swift on the server, not to necessarily build a company on, but just to see what the possibilities were. So when Swift was open sourced, I created this website. It is nsdateformatter.com. I already need to rename it as of Swift 3, but dateformatter.com is already taken. This is a project that I wanted to accomplish a long time ago because like most of you, or probably most of you, you forget the date formats the minute you write them. And so I really wanted to create a website to use as an interactive reference to NS date formatter. The problem is that I'm a Ruby developer on the server, and the rules for date formatting are just different. And so I made this when Swift was open sourced, and I wrote the entire thing in Swift. I put it on a $5 a month Linux VPS. I have a little tiny secret. Just to test to see if it was working, I ran the command to run the web server. And for any of you familiar with Linux, just raise your hand if you're familiar with Linux servers. Okay, a lot of you, good. Okay, so if you run a command and then you're like, oh, I just want to leave that running and log out of my SSH terminal, it's got a bit of a problem because when you disconnect, it'll close the process. So a really cheap and dirty way to do this is to use no-hup, which means no hang up, and then fork at the end of the command. So you say no-hup, and then your process name, and then fork. It disconnects from your terminal session, so now I can just exit the terminal. And I have never touched it since. Never logged into the machine. It got plenty of press and has received quite a bit of traffic, and I've never rebooted it. I've never done anything with it, actually. It is open source, so you can take a look, and I'll show you the GitHub URL later. Okay, so a bit of a timeline. So in September 2014, Swift 1.0 was released. A year later, we got Swift 2.0. Swift was open sourced just in time in December. And now we have Swift 3. So things are moving really rapidly. What I'm going to talk about more is just the open source nature of Swift and what that means. I was really pleased to see that Apple put all of this on GitHub. So there is a number of repositories that exist on the github.com/Apple. We'll talk about some of those. The first one is the Swift language itself, the compiler and the debugger, and there's full commit history, which I think is kind of amazing. Having seen this transition from other companies to open source more of their stuff, a lot of times they give you like a sanitized, like here's one big commit. But if you look back, you can see, you have all the history here. And this is an active project. I took this screenshot a few days ago, but as of the time I took the screenshot, there was a change that was happened just 3 hours ago. You can see also at the top here, 42,900 commits. And I think this is a really fascinating thing if you're interested in languages or compilers to go study it. Like, where did it start from? Everybody has their initial commit on every project. It's probably a README or something of the sort. You can go back all the way to the very first commit and see Chris Latner's first commit. You can also see that they were using Subversion at the time. Look at the date. So Chris Latner is the only one in the world who has 6 years of Swift experience. I did see a shirt somewhere. Somebody had a shirt that said, I have 5 years of Swift experience. That was an excellent shirt. Okay, but this commit actually had nothing in it. The very next commit had a makefile. And I think it's really kind of interesting to take a look at these and just study them as a way, Chris Latner is a brilliant mind, and I want to see how his mind works. And so I took a look at these, and I didn't understand a whole lot of it, but it just makes me appreciate the fact that he is in our community. The second thing they open source is the Swift core libraries. And what does that mean? Well, first of all, foundation. So many of the classes that are central to us as iOS developers are open sourced. Not all of them, but most of the ones you're going to need. XCTest from day one was ready to go. That means that when you create an open source Swift project, you can test it using XCTest. And libdispatch. This is not available on Linux yet, but I think it's coming. And so you can do threading and GCD and that sort of thing. The next thing they released is the Swift Package Manager. The Swift Package Manager is a way to define the build process for an application, what they call a package, to define your dependencies, to resolve those dependencies, not unlike CocoaPods or Carthage, to generate Xcode projects, and to test your project as well. So we'll interact with the Swift Package Manager in a bit. So this defines how modules are built. It defines what dependencies we're going to use are and what their versions are. And it heavily, heavily, heavily relies on convention over configuration. So there is no Xcode project. There may not even be any Xcode, which kind of makes me smile. This is essentially the Xcode project. It's a package.swift file that exists in the root of your project. You import the package description module at the top. You define something called a package. You give it a name and some dependencies, and that's all you need to do. In fact, the dependencies, since it's empty, could be omitted. This is enough to build a project. As long as you put your sources in the sources folder, as long as you put your tests in the test folder, everything is good. And if you deviate from these conventions, then you can specify the locations of your source files that you need to build. So it ends up looking like this. If you're building a command line app, you have a main.swift, that becomes your entry point, and you have a package.swift at the root. Okay, the other thing they open sourced is the Swift evolution. So this is how changes to the Swift language get proposed, discussed, rejected, or ultimately approved. And you can go look at all of them. This is a tool they use and respect deeply to make changes to the language that stay true to the language, to discuss things, even controversial things like this when they remove the plus plus and minus minus operators, which are not necessarily needed in a modern language, but a lot of people just kind of cling to it because it's how it's always been. Okay, so let's play around. I'm also crazy like John. And anybody ever deploy on a Friday night? Okay, good. I'm about to live code Linux right before lunch. To do this, we're going to leverage Vagrant. Vagrant is an easy way to spin up a virtual machine and then tear it down again. And so if you want to use Vagrant at home to play around on your MacBook or whatever, it's a really nice way to do that. I'm also going to use Vim because, well, all right, good, some claps. All right, also because I'm a masochist. Okay, I'll give you just a second to snap a picture of this URL. If you want a copy of my really minimal Vim RC to do development on a Linux VM, you might want to grab that URL. This is going to do things like really simple things like indentation and code highlighting for Swift, and just some really minimal things that I just cannot live without. Okay. We're also going to use Ubuntu. Ubuntu is the only officially supported Linux distribution that they give you pre-built binaries for. I imagine somebody who knows a lot more about Linux than I do could probably get this to work on any distro, compile the source themselves, etc. But if you just want to download from Apple the latest Swift snapshot, then you're going to want to grab either Ubuntu 14.04 or 15.04, 64-bit. The code name for that is Trusty Tar. Ubuntu has this really kind of cute naming scheme for their releases. There's always a mnemonic with the letters. I have no idea what a tar is, so I looked it up. That's a tar. Okay, we're about to step into the void. Things may go wrong, and I hope you'll forgive me. Hopefully the network will hold up, and let's go ahead and get started. So to save you a bit of pain, when you first spin up a new Linux VM, you're going to need some dependencies on your system to make everything work. So that is git, clang, and libicudev. And some other packages that you install might need some other things, but this stuff is pretty covered in the Swift documentation. So I've already done this on my VM, so to save you from the apt-get update on stage. Okay, so let's step into the demo. Okay, how's the font size? Yes? Okay, good. All right, so I'm sitting in a terminal on my Mac at the moment, and I have a Vagrant VM, which is defined by this Vagrant file. You don't really need to study this or anything, but the only things I want to call out is the fact that I'm using a trusty 64 box, right? Trusty is the code name for the 1404 that we're using. And then I have a forwarded port. So the forwarded port on the guest, which is the VM, is port 8000, and on the host, which is my Mac, is port 8090. And then I have a synced folder in case everything burns in holy fire. I can hopefully resurrect a pre-baked turkey to show you. Okay. To get into the VM, you Vagrant SSH, and this will SSH into the VM. So now I'm sitting inside the VM in my home folder, and the only thing I have on here were those 3 packages I showed you earlier, and I've set up the Vim the way I want it. Okay. Also in the demo folder, so I don't have to download it, we have this Swift 3 release, Ubuntu 1404. This is the thing you would download from swift.org. It's literally, you go to swift.org, click downloads, this is one of the links on there. Okay, so I'm going to unzip this. To unzip things in Linux, you're going to use tar xzvf, which is extract, zip, be verbose about it, and this is the file name, and that's demo swift. Okay, so this extracts everything that we're going to need. There is a user bin folder that we're going to step into. In fact, to avoid myself having to type this long thing, I'm actually going to move that into just a Swift 3.0 folder, which is a little bit more sane. And then inside of that, we've got a user bin folder. So these are all the binaries that came pre-built for Ubuntu. Inside of here is a Swift binary, and I'm going to do -- version to see that we are running Swift 3.0. But I don't want to have to specify the full path or CD into this folder every time I want to run it. So what I'm going to do is print the working directory and copy it. And then I'm going to go into my profile. And right about here, we're going to redefine the path to be that folder, prepending onto the existing path. Then I can source that profile. And now if I type which Swift, I always get this version. There is some weird Python library that Ubuntu knows about. So if you try to type Swift before you've done this, it'll say, this is not installed. Please install with pip. I don't know what pip is. It's a Python thing. I assume that will get stamped out in history because the iOS Swift is much more popular. Okay, so sitting in my home folder, let's create a new project. How many people here are familiar with rock, paper, scissors? I don't know how much of a cultural thing this is. Okay. Okay, so rock, paper, scissors. It's the game. You say 1, 2, 3, and you either give a rock, you give a paper. Oh, I'm getting there. Okay. A rock, a paper, or scissors. Rock beats scissors. Scissors beats paper. Paper beats rock. Okay, so let's make this game. I'm going to go into this new folder, right? It's empty. And I'm going to type Swift package init. By default, it's going to take the name of the folder as the name of the package. Okay? Then I'm going to step into that, and let's take a look at package.swift. We've got an import package description at the top, and it's just got a name at the moment. If we take a look at the other things that were generated, we have just a simple struct that says hello world, and they also give us tests. How kind. So there is a test that asserts that that struct does give us hello world. Okay. There's also this static var all tests. There's a little bit less magic here. There's no Xcode, so it can't infer what the tests are. So if you were to write more tests, you would add them to this all tests property here. And then there is a Linux main that is responsible for running all your tests. So if you add another test, you're just going to sort of append onto that array. Okay. Let's go into rps.swift, and let's just create a RPS game. There are multiple versions of this game. And so let's go ahead of time, and we'll just create an RPS mode. I'm going to start off with the traditional mode. And I'm going to defer to the enum to tell me what the different choices for this mode is. So we'll have a choices property that returns a string. And then here, I'm going to switch on self. And then in the case of traditional, we're just going to return all the different choices for rock, paper, scissors. And because this is 2016, of course, I'm going to use emoji. So we've got rock, we've got paper, and we've got scissors. Okay, good. Okay, so when we initialize our game, and can everybody read this at the bottom? Is that still okay? Okay. In fact, I can add a few lines there to make it a little bit easier to read so you don't have to stretch. Okay, so we're going to have our mode, which is RPS mode, and then we're going to have an initializer for our game. Okay, here we'll set the mode up, and then we're just going to have a func to make a choice, which will just return one of those strings out of there. Okay, so here we need access to a randomization function, and we might use arc4random or arc4random uniform, but we're not on Darwin, and that doesn't exist. We are in Linux, and so we have access to a new one called glibc. And in glibc, we have all of the standard Linux functions that you might already know about, like random. So if I have my choices, which I'm going to get from the mode, then I can just return choices random mod choices.count. Okay, let's do a build. This is done by typing swift build in the root of the project, and I have a little vim shortcut to make to do that. So that compiled fine. Okay. Let's make this a command line application. So here I'm going to create a main.swift. We do need to seed our random number generator. So I'm going to use nsdate to do that. So we're going to import foundation. We're also going to import glibc. I'm going to get the seed, which is going to be today's date, time interval since 1970. And then I'm going to call srandom. Converting that to a uint32. Okay, does that build? Yes. Okay, notice that in addition to the compile step, we also have this new thing, .build/debug/rps. That is our binary. We now have a binary that we can use. And I can quickly remap leader shift R to execute clear and .build/debug/rps, and then carriage return. Okay, oops, oh my goodness, thank you. So if I build here, and then I just type print hello, I can run it. Oh, I have to remember to build every time, then I can run it. Hello. Okay, so now we have a working command line application. What I want to do is create a new game, and that is going to be RPS game with a mode of traditional. Okay, so the next thing I want to do is, let's say I'm going to count 1, 2, 3, just like you would in real life. So let's say for count in 1 to 3. We'll print that count out. And then we'll sleep for 1 second. And at the end, I'm going to print the game's choice. Okay, let's build it. Everything's building. Okay, so I'm going to play with the computer here already. Okay, 1, 2, 3. Oh, I lost. Okay, thanks. Okay, so I heard somebody say there's about 300 people in the room. I feel bad that I'm playing this game and nobody else is. So I'm going to say for underscore in 1, 2 attendees. And we're going to print this out, and we want to give ourselves a little bit of a spacing, so I'm going to change the terminator to a space instead of a new line. Okay, so let's go ahead and build. Okay, and on the count of 3, everybody rock, paper, scissors. Okay, ready? 1, 2, 3. Okay, did you win? Did you win? Okay, some of you won. Excellent. Okay, and as you know, there is another version, or there are multiple versions of this game. One of them is Rock, Paper, Scissors, Lizard, Spock. In the case of Spock, which needs to go here, in the case of Spock, we are going to return all the choices from the traditional. So that's RPS mode dot traditional dot choices, and then I'm going to add on 2 more options. So we'll grab Spock, and there's no lizard emoji, so we'll do a snake. Okay, so I believe the rules of this one are Spock vaporizes scissors and rocks, paper defies Spock, lizard poisons Spock. Did I get them all? I forget. Rock and scissors beat lizard, but paper anyway, okay, it doesn't matter. Okay, so now we've got another mode that we want to choose from, but I want this to be a command line app, right? I want to provide the option from the command line to play this game in either mode that you want. So to do that, I'm going to use a dependency. So we're going to define some dependencies here. This is going to be a package with a URL of a GitHub project, github.com/Kyle F. This is Kyle Fuller. He's got a lot of great stuff with open source Swift. This one is called Commander. And you specify your versions here. So major version 0, minor version of 5. So this way I can pin on a semantic version of this particular library that works with this version of Swift and other libraries. Okay, and let's compile. At this point, when I do the build, it actually clones that project and brings it into the packages folder. Come on, internet. Okay, now it's compiling both of those. And now we have a Commander project that we can grab here. The way this works is you define a command like this with a block. And I'm just going to put, oops, sorry, not in here. What am I doing? In our main.swift, we're going to import Commander. And then we're going to let main equals a command. And I'm just going to take all of this and put it in the block. Then at the bottom, I need to say main.run to run this command. All right, I'm going to build it. Okay. The nice thing about Commander is you can specify options. So I'm going to specify an option on the command line called mode. The default is going to be traditional. And then you can specify an optional description if you want. I'll just say yada, because I don't want to write a lot. Okay, so now we have an option. When we specify something here, it will yield this option to the block. And so now I just need to have the mode, and I'm going to call this the user mode because this is user data. It may be garbage. And then back in rps.swift, I'm going to make this mode be a string type enum so that I get the raw value initializer. So I can initialize with a string and see if we got a valid mode. Okay, so back in main.swift, here I have a user mode. I'm going to guard let mode equals rps mode with a raw value of whatever the user entered in. Otherwise, we're going to be a good Unix citizen, and we're going to print out invalid mode, pass in whatever they gave us. And then we're going to give, sorry, not a fatal error. We don't want to crash. We just want to give a non-zero exit code. So if you're piping 2 commands together with ampersand, ampersand, then it's going to fail and not execute the latter part. Okay, so now we've got a guard for our mode. Now my mode I'm going to pass in here to the game. And I'm going to build, make sure everything is good. And then I'm going to step back into the terminal and manually call build debug RPS and call -- help. And this is behavior given to us by Commander, which prints out a nice usage description for our command line app. It tells us that we have a mode. It gives us the description. So I'm going to run that in the mode of Spock. And there we go. Okay, and just to check that it does work when you enter an invalid one, it says invalid mode Spock 222. Okay, so it would be really cool if we could put this same thing on the web, right? So what I'm going to do is step into another folder here. And in this folder, it's the same project, but in our package.swift, we are depending on IBM's Katura framework for web applications. Just a quick note, the NS date formatter site was built with Frank. Frank is kind of like Sinatra in the Ruby land. It's really, really simple to get started, but it hasn't been updated for Swift 3 yet, and so kind of sad face, we'll use the big evil corporation's kind of nice open source project. Okay, so it is major version 1, minor version 0, and I've already installed it, and I've moved. You can see that they actually include a lot more projects as dependencies. And in the sources folder, I've moved the command line stuff into CLI.swift, and I've moved the web-related stuff, which will go over into web.swift. And now our main.swift, now, in addition to the option we had before, I added a flag. So on the Unix command line, right, you have -- mode Spock. That was an option that has a value. The flag is just it exists or it doesn't exist. It's a true or a false. And so this is the flag of web, which will run the web server instead of running it as a command line app. And so depending on which mode we've picked and whether or not we're web, we're either going to start the web server or run the CLI version of the app. Okay, so going over to the web.swift, this is Katura. It's also pretty simple to get started, and it has a lot more features than Frank does. So you know, if you need middleware or caching or any number of things, this might be a good choice. You start out by defining a router. A router is going to handle the incoming requests and pass them off to some block that's going to handle them. So we've got a router here, and I'm specifying that when somebody issues a GET request for /, meaning the root, on that router, this is what we're going to do. And this block that gets executed will be given the request, so you can inspect, you know, the IP address or any of the request headers or anything like that, any form data, the response, which is we might add things to, and then next, because this is a middleware-driven solution, basically you might not be the only thing in the chain for processing a request. Like you might have middleware at the beginning that does authorization to make sure that you have the right cookies or the right headers or whatever. Next is what you would call. Say, I'm done, and the next one in the chain can process. And it's possible to do middleware before requests are handled or middleware after requests are handled. Okay, so here we're adding to the response headers that we are rendering some HTML. And it's important to add this charset UTF-8 because our content is emoji, and if you don't have this, then it will render like some weird string. Then we are sending down some data. Notice that there's multiple sends here, so this will actually send it down to the client. And so we can call it multiple times. And then all we're doing is outputting game.choice in a large font in an H1 tag. Then we call next when we're all done, and our web server is defined. Okay, now I just need to tell it what port to run and which router to use. So here at the bottom, we're saying run on port 8000, and go ahead and run. Okay, let's go ahead and build this. So there's a lot more code involved in the Katura framework, so it takes a little bit longer to build. And once we're done, we can run it, and we'll pass the -- web flag to start the web server. There we go. Okay. And we're linking. Okay, so I'm going to go into the build folder, into debug and RPS, and do -- help again. Notice that at the bottom here, maybe a little hard to read, but there's a -- web flag, which will run the command line server, or sorry, run the web server instead of the command line. And we can also pass in a mode of Spock to use Spock on the command line. So now it's running on port 8000, the same exact application, but instead of running a command line, it's running on the web. Now let's step over to our host machine, and let's just go ahead and get to localhost port, what did I say it was? 8090 was the port of the host, and Vagrant is mapping those two. Okay, so now I can just refresh the page, and you can play rock, paper, scissors, lizard, Spock. Okay, if you guys are interested in the source for NSDate formatter, or if there are any localization issues, which certainly happened a couple of times, go ahead and take a look at this. I am probably going to be updating this for Swift 3 and maybe just use Katura for it, as a way to teach myself something new. But the site is open source and I accept pull requests, so if you're interested in contributing something interesting to that site as a useful reference to the community, feel free. So what else can we do? Real quickly, there are plenty of popular libraries that already have Swift bindings, like Postgres or Redis. So if you really want to build a serious web application, you can. You'll probably run into some sharp edges here and there, but it does work. If you have a favorite C library, there are tons of great C libraries out there, and it'd be nice if, as a Swift developer, you could just leverage them. You can create a module map file as a package, and just wrap an existing library. So this is an example of wrapping the curl library, linking with the curl binary, including some headers and exporting certain symbols to Swift. When you do this, though, when you're using the package manager, you have to have a Git URL, so Git repository with a tag. So here I'm making one commit, giving it a tag, and once I've done that, I can reference not only GitHub URLs, but any local Git repository as well. And so here I'm just saying, give me the package on the local machine, and it will install it. The only caveat here, and maybe this will get better over time, but if you're doing active development on that project, like if you have multiple packages and they're referencing each other, you do have to update the tag every single time, which is quite annoying. Or overwrite the same tag every time and blow away your packages directory, build again. That would also work. The point I really want to leave you with is it's still early. We're talking about 10 months of open source Swift. It's a baby still. And there's so much opportunity. There's so much to explore. And when you look at other communities, the Ruby community, the Node community, just how much stuff people can create, I think the field is wide open to create cool things using Swift on Linux. Thank you.